Hello there, Mr. Sutton bringing you the AB Calculus 5-3 classwork solutions on definite integrals geometric approach. On this first problem, we want the definite integral from -1 to 2 of 3 dx. So that's just the area under y equals 3, this horizontal line here, between -1 and 2 for x values. So we're going from -1 to 2. That shaded area there is just a square. So we're essentially doing 3 times 3, or 3 squared, which gives us 9. On this problem, we want the definite integral from -2 to 4 of x over 2 plus 3, this line here that has a slope of 1/2 and a y-intercept of 3. We're going from -2 to 4. That gives us a trapezoid that we're finding the area of. So that's going to be a 1/2 times the height of, this would be 6 in this case, times base 1 and base 2, so that would be 2 plus 5. So we've got essentially 3 times 7, which is 21. For this problem, we want the integral from 0 to 5 of 2 minus x, the area under this line between 0 and 5 over here. So that gives us actually 2 triangles that we have to find the area of. So for the first triangle, we're going to have positive area because we're above the x-axis. So that's going to be 1/2 times a base of 2 times a height of 2. For the other triangle, that's going to be negative area because we're below the x-axis. So that's going to be minus 1/2 times a base of 3 times a height of 3. So we end up with 2 minus, well, let's see here. This is going to be half of 9, so 2 minus 4.5, which I'm just going to use a decimal. That's going to come out to -2.5. On this problem, we want the integral from -4 to 0 of this crazy square root expression, which you may recognize is a semicircle with the lower half of the circle graphed. That's this circle here. So if we're going from 0 and -4, from -4 to 0 rather, that's this quarter circle in here. Because that's below the x-axis, this is going to be negative area, and we're going to have 1/4 of pi r squared. So this is going to be -1/4 pi times the radius of 4 squared. And if we want to simplify that, well, this is going to be 16 pi. -1/4 of 16 pi is going to be -4 pi. On this problem, we're trying to find the integral from -1 to 1 of f of x, which is given on the graph here. So we're trying to find the area under this semicircle, but that's going to actually include this area as well. So we don't just have a semicircle, we've also got a rectangle thrown in there. So we're going to need 2 area formulas. Let's do the semicircle first. So we're going to have 1/2 times pi r squared. Now what's the radius here? Be careful. The scale is actually that we're going by 1/2 for each grid line because the 1 is on the second grid line. So this is actually a radius of 1. So this is going to be 1/2 pi times 1 squared, which is actually easier to find anyway. And then we also have to add the area of this rectangle, which is going to be a base of 2 times a height of 1. So that's going to be pi over 2 plus 2, which we can just leave the way it is. For this problem, we want the integral from 0 to 3 of absolute value of x minus 1 dx. So for this one, we need to graph out the absolute value of x minus 1, and then find the area between that and the x-axis, between 0 and 3. So let's go ahead and do that. This is just going to be a normal absolute value function, just a v, but this -1 is going to shift us 1 to the right, which is going to make a difference. So we're actually turning around at +1 here. Now we want the area between 0 and 3, so that's 2 triangles. For the area of the first triangle, we've got 1/2 times the base of 1 times the height of 1. For the second triangle, we've got 1/2 times a base and height of 2. So this is going to be 1/2 plus 2, which is 2.5, or 5/2. Choice D. On this problem, we're given a piecewise function between -1 and 4. We want the value of the integral from -1 to 4 of f of x dx. So this is the graph of f here. If we're finding this integral, we essentially want the area between this graph and the x-axis. All right, so we're going to have 2 types of area. This trapezoid up here is going to be positive area because that's above the x-axis. This other trapezoid down here is going to be negative area because that is below the x-axis. So let's do one area at a time. We've got 1/2 times a height of 2 in this case, times the bases, let's see, this is going to be 3 plus 1. And then for my other area, I've got 1/2 times a height of 1 times parentheses the bases, we've got 2 plus 1 there. And now let's crunch the numbers because all the answers are simplified. So the half and the 2 cancel, so this is 4 minus, this is going to be 3 halves, 4 minus 3 halves. So I guess I'll call that 4 minus 1.5 because I've got decimals in my answers. That's going to be 2.5, which gives us choice B. This problem was a little bit tricky. If integral from -1 to 1 of e to the negative x squared equals k, then they want to know the integral from -1 to 0 of that same function. So the key on this problem is recognizing that this is an even function. Because of this x squared here, this is going to be an even function because if you plug in negative and positive numbers, you get the same result. So that means that this function is symmetrical over the y-axis. And what that means is that since you're going from -1 to 1 with this area, since you're going the same distance from the y-axis in both directions for this area, that means that this -1 to 0 is going to be exactly half of this total area because you've got another symmetrical half on the other side between 0 and 1. So if -1 to 0 gives us half the total area, and the total area they told us was this k constant, then we just need half of k, which is k over 2. Choice D. On this problem, we're trying to take the integral from 0 to 2 of square root of 4 minus x squared dx. The key on this one is recognizing that this is a semicircle that's based off of the circle x squared plus y squared equals 4. So this is a semicircle with a radius of 2. And this is centered at the origin, so we've essentially got a semicircle at the origin, and we're trying to find the area between 0 and 2, which is the right edge of the circle. So we're really just finding the area of a quarter circle, which means that we're going to be doing 1/4 times pi r squared. The radius, as we said, is 2, the square root of 4. So this is 1/4 times pi times 2 squared. Let's see, 2 squared is 4, so 4 pi times 1/4 is just pi, giving us answer choice C. On this problem, we have the graph of f as these two line segments, and we want to know the integral from 0 to 3 of the absolute value of f of x dx. So the trick on this one is that all the areas we're adding together have to be positive now because of this absolute value. So for example, this area between 2 and 3 that's under the x-axis, this would normally be a negative area, but now the absolute value is going to force us to add that instead of subtracting it. But that actually makes the problem easier. Now we're just automatically adding everything. So let's go from left to right and find those areas. This first area, we have a trapezoid with, we'll call this a height of 1 and bases of 2 and 1. So that's going to be 1/2 times the height of 1 times parentheses base of 2 plus 1. And then we've got, let's see here, this is going to be a triangle with a height of 1 and a base of 1, so 1/2, 1 times 1. And we've got another triangle with the same dimensions. So adding all this stuff together, and I wrote my trapezoid formula a little bit differently, but it's essentially the same thing. You're doing 1 plus 2, taking half of that and multiplying by the height. So we end up here with 3 over 2 plus 1 over 2 plus 1 over 2. Well, this ends up being 5 halves, which gives us answer choice D. Now, for those of you who thought this might be non-existent because of this discontinuity, since it's just a jump and it's not an asymptote, you actually can calculate these areas.